All right, last Monday, we started talking about stuff. In particular, we talked about how the computer moves things back and forth from memory. But before we do that, let's just review our important things. What is an algorithm? What is a program? Everybody gets candy. Whoa, sorry. Oh, sorry, that was a bad throw. Anyone else? Okay, algorithm program. What else did we talk about? Last time we talked about division. If you divide an integer by an integer, what do you get? If you divide a float by an integer, what do you get? If you divide a float by a float, what do you get? Okay. What happens, and this is, I'm going to raise your hand for this one. What happens if you divide an int by an int and you put it into an int? Who's got an answer for me? You divide an int by an int and you store the result in an int. What do you get? You get an int. If you divide a float by an int and you store the result in an int, what do you get? You get an int. What happens if it was a float before and now it's an int? What happens to all the decimal places? They're gone. Okay? And we'll see that more today. So, integer division. Some things can be cut up into little pieces, like, unlike people, give me all that candy back. So, cake you can cut into little pieces. Can you cut people into pieces? Not legally unless you're a surgeon, right? Under very few circumstances, or maybe in the army under terrible circumstances. Okay, so that's everything. So what I would like to do is I'm going to give you a handout. We're going to start with a little handout today. So there should be enough for everybody if you pass it around. I'm obviously not good at dividing these up. There's two. There's one on the front, one on the back. We're going to do the one on the front now. It's called memory and output, and we'll do the other one that's on the back later. Okay, so hold on to these. You'll probably want them later. So there should be enough for everybody. Just if you end up with extra, pass them to each other side doesn't have them. And this is one of those partner things. So find a partner. One of you be the listener, one of you be the solver. Don't be shy. You have 3 minutes. Ready? Go. All right, one more minute. All right, are we ready to look at this? Show of hands, who's programmed before? Please do not answer any questions for the next 4 minutes. Everyone else, who is done? If you didn't raise your hand a second ago, who is done with this problem is willing to talk? You haven't programmed before? You haven't? Have you? You have, okay. Well, you can talk me through this, okay? So I'm sorry I forgot to bring the code put on the screen, but you have it in front of you. If you look, you notice off to the left there are some light gray numbers which indicate line numbers. Often we do this to help us talk about code so we know where things are. They are not part of the code. They are just there for us to reference. So starting at line 1, what we're trying to do is we're trying to track what the values of x, y, and z are and what is output by the program. So, sir, take me through this line 1. What happens?
Line 1, x and y are not declared.
So what's in the, what do we put there?
We don't put anything.
What values in there? What value are x and y?
There is no value. It just says
Okay.
x, y,
Is there, what value is stored in the box labeled x?
we don't know.
We don't know. You're absolutely right. We don't know. Remember, if we don't initialize a variable, what is in there? Could be anything, right? It could be anything. So for x and y, we don't know what's in there because they were not initialized. How about z?
Z equals 0.
And what is output? You're right. If it doesn't say C out, there is no output. Does line 1 say C out? It does not, so there is no output. I'm going to put some dashes there. That doesn't mean dashes are output. It means that there is no output. Okay, great. Line, you've done a great job. Here. Who wants to do line 2? Who hasn't programmed before? Come on. Yes, sir. Okay, so y gets a value of 1. That's great. What's x? Oops, sorry. What's x? Still unknown. Y is 1. What happened to z? It's different now, right? It stays 0. It is not different. What's output? Why isn't there anything output? Because there's no C out. Okay, by the way, anybody have nut allergies? I should have asked before bringing. You do? Is this, are candy bars going to be a problem for you? You sure? Okay, thank you. I should ask that the first day. So if you ever have any problems, let me know. Okay, we can, like, I can throw them and people can just eat them later on their own time. How's that? You're okay? All right, sorry about that. I should ask. Okay, line 3. Who wants to do line 3 for me? I'm sure you do. Go ahead. You made eye contact. You messed up. Yeah. What's your name? Maddie? Okay, Maddie, go ahead. Why is x 1? Okay, so x equals y. So the assignment operator always goes left to right. So whatever's on the, no, right to left. Sorry, whatever's on the right side gets copied into the left side. Did I say that right? Correct? Wait, right-handed, left-handed. Yeah, so things go from right to left. The value on the right gets copied over the left. So when you see x equals y, the computer goes, oh, I know what's in y, because we just did that. What's in y? And so x becomes equal to, so yeah, so now we know we have 1, 1, 0. And what is the output here? Nothing. Why is there no output? No C out. There you go. Okay. Who wants to do line 4 for me? It's the easy part. It gets tricky later. Roberto, I know your name. We'll go. Uh-huh. Uh-huh. Yes. Okay, let me say one thing. You are correct, but your process of reasoning will get you into trouble. So what you said is that line 1 says z is equal to 0. Therefore, it's 0. Don't worry about what happened in line 1. Okay, what you worry about is what's currently in this box right here. Now, z hasn't changed, so you're fine, but don't go thinking that when there's a value you can look back and see what it was. You got to kind of track what's going on inside. Right now, it seems absurd that I'm saying this because it is so evident that z is 0 that I shouldn't even, but later it will not be evident. The things will be more complicated. I will be doing things to trick you where values change behind the scenes without ever being called. Yeah, we'll get there. So, but not until I've had a chance to trap you in the class with no chance to escape. Okay, then we'll get to the hard stuff. All right. So x is, all right, so we're in line 4, right? X is still 1, it hasn't changed. Y equals z, so what happens to y? Z is, what's output? Why not? Because it doesn't say C out, absolutely. Okay. Line 5, who wants to do this one? You made eye contact, you messed up. What's your name? Mm-hmm. Oh, I was in front of you. You can go next, though, if you want. What's your name? Kate? Okay, Kate. What happens on line 5? You can say pass if I'm embarrassing you, and we'll go to Kevin. X is 1, Y is 0. Yep. Z is 0, and there's no output. So what does this line do? What does line 5 do? That's right. It goes and looks in the box named Z, but then it doesn't do anything with it at all. Okay, good. So that's a trick one, right? Why would we put that in our program like that? The answer is we wouldn't. That's just an evil professor thing to throw in there to confuse you, okay? So I will do things like that. All right, Kevin, so I know your name now. What happens here? Line 6. Uh-huh. Yeah, and what is it? Output. Whoops. Exactly. So C out outputs the thing that's in there. Going long here. Yes, sir. Nope. The computer literally, we'll talk about input shortly. You have to tell the computer how to format things. The computer is dumb, stupid, but it's stupid very, very fast. It will not naturally look at what you're outputting and make it nice for you. You will have to do that if you want to. And we'll talk about how to do that later today. All right, I have 4 pieces of candy left and 3 things, so we're good. Who wants to do line 7? Yes, sir.
So the line is saying that the value of z is set to x plus y,
Uh-huh.
which is 1 plus 0, so z would be 1, and the output would be none because there's no c out.
Exactly. Z changes to be equal to x plus y. Okay, Z changes to be equal to x plus y. What's in the box named x? 1. What's in the box y? 0. So 1 plus 0 is 1. Easy enough. Now, let me ask you a question. Back in line 4, y was equal to z, wasn't it? So why doesn't y change to be equal to 1 here? Yes, sir. Because that was, exactly, it was someplace in the past. We only go line by line. Okay? We only go line by line. We only go forward in time. We never go backward in time. There is no magical link between those 2 boxes. Yes? No, sort of. So the question was, does each line only depend on the light before it? No. What happens is each line depends on the state of the memory, of what's in all those memory cells, and what's in that line. Does that make sense? So the state of all the memory cells depends on what was in all the prior lines. But when you execute a particular line, it executes with whatever state is in memory, whatever boxes are right there. Does that answer your question? Yeah? Yeah, we'll talk about output formatting in just a second, okay? After we finish, we'll do a little bit of math. I'll give you our outline today. We'll do some math. We'll do some output. We'll talk about some other data types. We've talked about a few. We'll go home. I'm going to get a pizza from the farmer's market right in front and have lunch. That's my plan. So, Other questions? But we'll talk more about output. I know you're curious. All right, line 8. Line 8. So nothing goes back in time, right? The whole point of line 7 is nothing goes back in time. It just doesn't. Line 8, who would like to do line 8? You made eye contact. Obviously, you made a big mistake. What's your name? Tiffany. I'll try and remember. We passed on the sidewalk the other day. Okay, go ahead. Exactly. So x acquires the value of z. What value does z have? Great. So x was 1, and now it becomes 1, right? It happens to be the same, even though it was changed. It doesn't change because it changed to the same value. Everybody got it? It changed, but the thing it changed to is exactly the same. Therefore, did it really change? Ask your philosophy teacher. I don't know. And then finally, one last output. Oh, wait. Here you go, Tiffany. All right. One last output. Who wants to do this one? Thank you. Okay. That's it. That's correct. Milky Way, no nuts. I saved it for you. I'm sorry if I've been throwing you things with nuts. Okay. So there we have it. What we've done here is what's called a program trace, or stepping through a program. It is a skill that you will be developing in this class. In fact, this type of skill is most of the midterm and final. Okay? I will give you code, and I will expect you to tell me what's in there. Do exactly this. Start at int main, name all the variables, step through, and just keep track of what's in each one. When you're done, you'll have an A, if you do it right. Sound good? And what I'll do is I'll give you increasingly complicated and annoying code that you have to figure out. Everybody good with that? All right, so that's the answer to that. All right, so let's talk about some math. Last time we started on math, we got through what? Addition, subtraction, multiplication, and division. And when we got to division, we talked about the different types of divisions we had, which we refreshed our memory of at the beginning of the class, right? What type of division gives you floating point output? Anything where the numerator divisor is a floating point number. Everything else gives you integer division, okay? And everything else corresponds to exactly only having integer, right? So if there's any floating point in the division, it becomes floating point. If there's only integers, it's integers. Floating point is like cutting up the cake with a knife. Integer division is like splitting things into groups, okay? So let me just set up some examples here really fast. Int x equals 5. Int y equals 2. Int z equals 0, okay? So we did a bunch of stuff. We did z equals x plus y. This is pretty straightforward. We can see out z and see what we got there. We can do z equals x minus y. It's pretty straightforward, right? Everybody good on this? Output it. We can do z equals x times y. We can output it. All right, now z equals x divided by y. I forgot the equal signs. X divided by y. And we output it. What is this going to give us? 2. 5 divided by 2, integer division is 2. What is left over? Pardon? 1. Okay, so when we're doing integer division, sometimes it is very useful to know what is left over. Let's say I say all of you I want to divide up into groups of 5 in this class, right? You will have some numbers of groups of 5, and then you'll have some left over. The way you can tell what's left over is what's known as the mod operator, and it is the percent sign. Like that. So we do plus, minus, times, divided, and then mod. So let's compile this and run it and just make sure it's working. All right, I'm calling this program math2.cc. If you know, oops, sorry, wrong compiler. There's another compiler named C++. We're using G++, so forgive me. And this, it's actually probably the same one, but let's just make sure. Okay, so G++, compile the file math.2.cc. This says this is the source code I want turned into computer code. -O means when you compile it, put the output in math2. If I didn't specify the -O flag, where would it go? A.out. But we're skipping A.out by doing that, and so now we can run this by doing math2. And here's what we see. We see 5 plus 2 is 7. 5 minus 2 is 3. 5 times 2 is 10. 5 divided by 2, integer division is 2. And then 5 mod 2, which means the remainder is 1. Yes, sir? Does the mod operator only work with integers? I believe so. You can test. We could put some floats in and test, but I'm pretty sure it does. So. And the reason is that, I don't know. I don't know. Yeah. Yeah. I'm pretty sure it only works with ints. Well, I'm not sure. You could do something weird. All right, I'm going to tell you something now that I shouldn't tell you. No, I'm going to save it for later. Because I don't want to confuse you. I'm not holding back from you. It's just, I don't want to confuse you all at once. Do you have a question? Okay. All right, so everybody good on basic math stuff, okay? Let me ask you a question. Say we want to do square root. How do we do square root? Anybody know? Yeah? All right, programmers are, but they're lazy in a good way. Could you do square root given only plus, minus, times, and division? Newton's approximation or something like that? Did you learn that in high school? Right? You could just sort of, there's a way you can iterate, and you can just do plus and minus, and you get closer and closer to the actual square root. So there's some way that you could do that. That would be horrible to have to do every single time because programmers are lazy and they don't want to do that. Instead, what they want to do is they want to write a library. Oh no. They want to write a library that has stuff in there that they like. Okay? And the library that we can use is #include. This is how we include additional libraries. CMath. Okay? #include CMath. And what this does is it gives us a bunch of additional math functions that we can call. So let's try one. I'm just going to do, let's say, z equals pow x comma y. Anybody want to guess what pow is? Power, I think it's exponentiation. What will pow x comma y do? It would be like 5 probably squared. So I'm guessing that this is going to be 25 unless I made a huge mistake somewhere. All right, we'll compile it. It compiles cleanly. We don't have any error messages. We'll run it, and sure enough, now we get 25 down here at the bottom. Okay. There are a number of things in the math library for you to use. There are sine, cosine, tangent, all those functions. There's power, there's exponentiation, there's absolute value, things like that. Okay? If you want to know what's in there, you can do one of two things. You can Google it. That's the easiest way. You can look in the textbook. I think, I forgot to write it down notes. I think it's around page 130 in the textbook. So that has a list of some, if not all, of the math functions that are in there. I will just show you one right now that you'll probably need when it comes project time. Oh, project, I forgot to talk about that too. I'll talk about that in a minute. Okay. Let's say x, y, z. Let's say w int w equals minus 132. Z equals abs w. What does abs do you think? Absolute value. So if we output z here, what are we going to get? We should get 132. All right, I'm going to clear the screen. I'll compile. It compiled cleanly. We don't seem to have any errors. We'll run it, and sure enough, we get 132. Absolute value. Okay. There's a couple other ones in there. Yep. The question is, what happens if you square root a negative number? And the answer is, I don't know off the top of my head, but I know who to ask. I suspect we're going to get an error. I don't think this type of math library doesn't do any symbolic operations, so I don't think it's going to give us eyes or anything. So there are other libraries that can probably do that. So we'll run it. Ooh, that's not good. I wonder if it's consistent. Yeah, it is consistent. So the answer apparently is bad things. Bad things happen if you find the square root of a negative number. So, all right, other questions? Everybody good on this? There's a whole bunch of functions in there. Yeah? All right, 1 minute quick break in place while I set up the next thing. Okay, welcome back. So I know that it's not cool anymore like it used to be like when I was young 4 years ago. How many of you are on Facebook? Anybody? Do you ever get things where your friends post, only the smartest people could ever solve this one, and it's like 1 + 1 + 0 times 1 + 0, and they have something, and everybody argues about what it is, right? All right, so this is what we're talking about right here, and it's the precedence of operations, right? When you're doing math, when you have some equation like that, how can you predict what is going to happen based on what's there? Anybody want to take a swing at this one, by the way? Yeah? Yeah, what's the answer? Wait, have you programmed before? Okay, go ahead. So he thinks the square root first, and then? And then negative 2 times 2, okay. And then do something with the 5. Okay. Yeah. It's not negative 2. The reason we know it's not negative 2 is there's a space there. So this is actually 5 minus 2 times 2 plus square root of 16. All right. Let me just tell you, this stuff's really annoying. It's horrible. I hate it. I'm just going to tell you the answer, and then I'll show you how people really do it, okay? Oops, wrong type of comment. All right, this is the order of operations. Pardon? All right, so the mnemonic, please, friends, excuse my dear Aunt Sarah, or Sally. What's wrong with Sarah? With or without an H? Okay, well, okay. So this is the remember. So P, what is P? Parentheses go first. F, functions. E, exponent. Do we have exponent in C++? No, we don't. Exponent is a function in C++. I just listed here because it makes the mnemonic easier. And then if you ever working in other computer languages, they might have exponent, and then you'll know. My, D, ant. Okay, so these are the orders of operation. So given this, how do we figure out what goes on in here? Which one do we do first? The square root goes first, so that will turn into a 4, because that is the function. Are there any other functions? Any parentheses? So which one do we do next? Multiplications, we do 2 times 2. This whole thing turns into 5 minus 4 plus 4. Then we do multiplication or addition and subtraction, and we're done. If we run this, we should get what? Let's make sure we get that. We get 5. Okay? That is the order of operations. Can you expect a question on the exam that will do this? No, you can't. Let's throw some parentheses in there and see if anything changes. Let's put parentheses around here. Now what happens? That goes first, so it becomes 5 minus 2 goes first, which is 3. Then what? The square root, which is 4, so we get 3 times 2 plus 4, which is 10. Okay. Now, on the exam, I can make these things long and completely horrible, and I just might do that depending on what kind of day I'm having when I write the exam. Okay. Yeah, question? No, the computer will do them in that order. So it'll do multiplications first. It doesn't, I don't think it, I think it does addition over subtraction. Did I? Why didn't it do 5 minus 8? Oh, maybe it is going left to right. I think you're absolutely right. Let me go back and see. It goes left to right. Let's see, let me think about this for a second. So if it does that one first, that one second, then it should do 5 minus 4 plus. All right, what we'd have to do is set up something that actually tested that. I'm not sure this tests that, does it? Here's the answer. The answer is I don't care. And I'm not going to give you something on the exam that. All right, we better test this and see. How about that? So let's try this. Let's do. It does? Why? So, because at some point we get to 5 minus 4 plus 4, right? Hang on a sec. Let's do this. X equals 5 plus 3. So is it going left to right? Who wants to make the case that the order matters for this? Because I don't see it myself, right? 5 minus 2, that multiplication happens first, because it happens in 2. All right. Yeah, we could worry about this. So the answer is I don't know. I won't give you anything that's ambiguous on the exam, okay? Can I promise that? Here's the deal, right? Don't write code that looks like this. Don't write code that looks like this. When you're writing code, yes, do you have a question? Is the square root always positive? It should be. It's not going to give you any I or imaginary parts. And when we tried it just a minute ago, remember we got that horrible. We had that question before, what happens if you do the square root of a negative number? And we got this horrible thing right there. It will always be positive. Yeah, it'll always give you the positive result. Yeah. Okay. So the answer is this is ambiguous, right? Who are we writing code for? We're writing it so the computer can execute it and humans can read it. If we all have to sit here and like think of these crazy rules, is it useful? No. So when I write code, I don't ever worry about this. I have to teach it to you because it's in here, but here's what I do. I go, okay, the first thing I want to have happen is 5 minus 2. The second thing I want to happen is the 5 times 2. And then after that, I want the square root of 16 to happen. If you look at my code, which you probably will be shortly, if you look at things that I have written, I always, 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 if it is a multi-step computation, nest the parentheses to ensure that the order of operations happens the way I want them to, rather than by this somewhat ridiculous rule. Okay? Does that make sense? So, what you want to do is when you write code, put the parentheses in that make the order of operations clear. If you're reading this code, you evaluate it from the inside out. You look at the innermost parentheses, do those, and then work your way out. If you keep being a computer scientist, someday you may run into a language called Lisp. Lisp has so many parentheses because it does this type of evaluation with math and with other things all the time. Okay? In fact, there's a lot of parentheses there. But this is the rule of thumb. Use parentheses to force the order of operations to be the ones that you like. I promise you on the exam that I will not give you something that doesn't have parentheses that is ambiguous. Okay? And if you follow just that order right there, I will give you credit for it. If you're reading other people's code and you're working on other people's code and you come across something like this, put parentheses in it. Some people will hate you, but I think it's just better because it explicitly makes clear what you want done. Okay? All right, everybody good with that? Okay, so any questions? 17-second rules in effect? All right, give me 1 second here. All right, so here we are. We have a new program. What algorithm does this program do? It just stops and starts. Doesn't do anything useful yet. Let's have it do something useful. Let's say that we have some integers. We have integer x equals 5, integer y equals 2. These are our familiar friends from before. And integer z equals 0, which we're just initializing. All right. Say we do z equals x divided by y. What do we get? 2. Why is it 2? Because it's integer division. What happens if we don't want integer division? Like say we had 2 integers and we wanted to do a floating point calculation. Yeah. We have to do something, right? It doesn't work that we can divide 2 integers and get a floating point number right now. Do you have a question or comment? We have to somehow change the integer to a float. Okay? So let me just put integer division here so we don't forget. And down here, if we do output this, we know we'll get 2, right? All right, if we want to do floating point division, though, we have to change one of those integers to a floating point. Any idea how we can do this using only what we know so far? Yeah? Nope, because this is an int. Yeah? Exactly. So a bad way to do this, and I'm just going to put this, it works, is do something like this. Float w equals x. Right? What happens is now w is a floating point, and if we do z equals w divided by y, we should get 2.5, right? Should we test it and see to make sure that everything's working correctly? The answer is yes. You should always test it and see to make sure things are working correctly. And we're calling this cast. We'll tell you why in a minute. Oh, no. It didn't work, did it? What went wrong? Yep. Z is an integer. Z is an integer, right? This is floating point. We changed it to a float, and we did float divided by int, but it didn't work. Why not? Because Z is an integer. So remember that. Doing floating point doesn't work. So let's do this. Instead, we'll say float Q, and these are all horrible variable names. We'll output Q. And should this be 2.5? All right. Now we get 2.5. Everybody understood what just happened there, right? All right. So this is the bad way. And the bad way is that we have to kind of declare these extra variables just to make something afloat, right? A float, that's annoying. So what's a better way? The better way is this. We say Q, and we need Q still because we're going to be doing output of floating point, equals okay. It says Q equals static underscore cast, open angle bracket, float, close angle bracket, open parentheses, X. What static cast does is it says, look at the thing that's in these parentheses and temporarily change its type to a float. In fact, it's not really temporarily changing it. What it's really doing is this whole thing, it looks at X and it goes, oh, I have an integer value. This whole thing becomes the corresponding floating point value. So now we have the floating point value of X over Y. What kind of division does that give us? Floating point. And so when we output it, it should be floating point. It should be 2.5. Okay. Excuse me? It changes the type of X. The type of X, right? X is its name. It has a type, which is an integer, and it has a value, which is 5. This changes the type, essentially. Not permanently, okay? X will still continue to be an integer after this. Yeah, Tiffany? I did. I declared it right up here. So I'm reusing the one that I declared up there. Does that help? Yes, sir. What's your name, by the way? Ashwin? Ashwin. Okay. If you put parentheses around the whole thing like this, what is the order of operations? The stuff inside parentheses happens first, so it would do integer division and then cast the result to a float. So it doesn't change both. Okay? It does what's inside the parentheses first. If you put it around Y, if you wanted to do both, you would have to do the whole thing again. The parentheses only apply once. They don't apply multiple times. You'll see why later in the semester. For right now, just accept that it's magic. Okay? Yep. Casting, well, I'm just going to tell you, casting in computer science is what you call when you change a variable from one type to another. Okay? Static cast means we're just going to do it once right here, and it's going to change. Okay? So casting is changing one variable type to another. Yep. Uh-huh. Yep. So if you want to get rid of this stuff up here, that's just there as an example. I would have to go put a float in front of Q here just to make sure that it was defined. Like that. Okay. But I'm not going to take the bad part out. This is just our example that we're working with, so we can see both works. Okay. All right, everybody with me so far? Who's with me? Who's against me? All right. What we have here is what's called the C++ style cast. C++ style cast. That's how the C++ language does casting. Oh. We don't need both, by the way. I only put static cast on both as an example. I'm going to take one off, okay? Just because you don't need both. Okay, everybody good? As long as you have one float in the operation, it is floating point division. Yeah?
Where is
Casting, well, where is casting? Yes, it's a function. But remember that we have parentheses here, and so that will be evaluated. Whatever's inside those parentheses will be evaluated and then put in there. Right now it's just x. If we had x, something else would be. We get a compile error. Yeah. All right, so what language are we learning? This is C++ style casting. What language are we speaking? Was English created out of whole cloth? What did it come from? Other languages, German, French, a little bit of Latin, things here and there, depending on words, right? What? Yeah, all sorts of things. C++, was C++ created out of a whole cloth? What language did it come from? C. So what you're going to find sometimes is that you can have code that does this kind of casting. I'm just going to copy this block so I don't have to type it all over again and put it back. And we're going to change this to a C-style cast. What happens in C is this. You just put the type and then parentheses around it. And that is the C-style cast. Both work. Both work. Okay. Well, let me prove that both work.
And that'll still be temporary?
Yep. Yep, it's temporary. Says temporary change x into float. What this really says, honestly, is it says in the math order of operations, float is just a function that says turn whatever values in the parentheses into a float and return that. So it actually does the computation, take x, turn it into a float, return that, and then work with it. So it doesn't actually change x. Okay. After this, x will still be an int, and it will not be a float. But it just says make that a float for the purposes of this operation. Everybody go on that? Yeah?
So why would you prefer to do the C++ over the C style cast?
Why would you prefer to do the C++ style over the C style cast? Because you're using C++. Right? I mean, I could speak in old English words. Why wouldst thou prefer, why wouldst thou suffer to typeth more questions, right? I mean, there's a lot of ways to communicate the same thing. Personally, I'd use the C style. Do you know why? Because I learned to program C first. So I try in my code, which you're going to look at eventually, to use the C++ file. Sometimes I might just forget. Yeah. It changes it. No, it doesn't actually change it. What it really does is it says, look up the value of x. What's x? And now create a floating point value that has that value. And so this whole thing becomes a floating point 5 divided by 1. I'm just using change conceptually rather than talking about the mechanical operation. Yeah? Okay. You want to see what happens if you do x equals float x? Does that permanently change it? Here's what's going to happen. The compiler is going to barf. Oh my God! The compiler is not going to barf, but here's what's going to happen. I was wrong about that. All right, let's output x and see what it is. I spoke too soon. Here's what this line of code does. What I predict is going to happen now that I've seen not barf is that it's going to just say 5, and it's not going to be a floating point. And here's what happens is it says take the value of x, which is, turn it into a floating point value, which is 5.0, right? You might think of it that way. Stuff that 5.0 into an integer. What do you get? So when you put a float into an integer, the decimal point goes away. So the computer, do you see what happened there? We turned 5, we got this value 5, turned it into a floating point, so it was 5.0, stuffed into x, which is an int, and so it goes back to 5. So sorry about that. I thought what I forgot, and anyway. So, yes, question. All right, let's try that. 2.5. Well, all right, so what it's going to do is going to take 2.5, which is a float literal. It's going to convert it into a float, which is, it's going to stuff it in x, which is an integer, so it'll lose the decimal point. Okay? All right, everybody good with this? This is casting. When you need to change one type to another for some computation, you use this. When you get further along in your computer science career, casting has other purposes as well. Okay? But nothing we need to talk about right now. Who's happy? If you're happy, you know it, stand up and take a 1-minute break. Go. All right, welcome back. So far we have talked about 4 different data types. What are they? Float, int, bool, character, okay? There are actually quite a few more. So what we're going to do now is talk over some of these other types, and we'll see why we need them a little bit, okay? All right, so let's say we have int x equals 0. What is an int? All right, how big can an int be? Really big, huh? All right, let's try this. X equals 4,897,234,812. How's that sound? All right, let's see what x is when we output it now. So I created a new program. This one's called types.cc. By the way, have you found all the code? Does it show up on Blackboard for you? So all the code that I do in class, I put on Blackboard. I also put it on CS class, and I can show you how to get it off of my account on CS class as well. So I hope you're not trying to write all this down. Types.o types. Oh, no. Something happened here that wasn't right. All right, here's the deal. Remember that we're dealing with boxes, right? Memory boxes. And they have a certain number of bits in them. Think of it this way. If the number is bigger than those number of bits that can represent, then you have a problem. Here's how I like to think of it. Anybody ever had a car, or driven in a car? How do you know how far your car has been driven? There's an odometer, right? How many digits does your odometer have? 6. So how far can you drive your car before the odometer has problems? 999,999 miles. And when you drive 1 more mile, then what does your odometer say? 0. When I was a kid, cars didn't last as long, so they didn't bother with 6 digits. They only had 5. And so every 100,000 miles, your car would go back to 0 again. Okay? The same thing is going to happen with numbers. So I'm going to show you one thing that you don't really need to know. This isn't going to be on the test, but it will give you an example. You can see what's going on. I have included this header file up here, this library called limits. And what limits does is allows us to do this. We can use this numeric limits int with a min or a max after it, and it will show us what the maximum size of things is. So here we go. We go C out, angle, angle, numerical, limits, limit, min, angle, ANDL. This whole magic thing right here, only thing you really need to understand is that there's an int, and it's going to show us the minimum value of an int. If we have min, we probably have something else. What do you think that is? Max. So here we go. We're going to look at the numerical limits of an int so we can see what's in there. That worked, thank goodness. So here is the range of numbers that we can hold in an int. If we look at, we go hundreds, thousands, millions. So it's essentially 2.1 minus 2.1 billion, give or take, up to 2.1 billion. Yeah. See that? Oh, was it? Oh, cool. I didn't happen to notice that. So he just pointed out that when we were messing around with, and by the way, I repeat things so that they show up on the YouTube. I'm repeating what he said is that this happens to be the same value as when we tried to do minus the square root of minus 132. So it gave us a weird value that happened. So, okay, how often do we deal with numbers that are bigger than 2 billion? It depends on what you're doing, right? Like adding up a professor's bank account. Sorry, we could use, if we wanted to add up my bank account, we could use something different, okay? And we could use a type that is called a short. A short. A short int is if you're dealing with numbers that are smaller. Now, it may be that on this computer, and I'm not quite sure what's going to happen, that a short turns out to be the same as, oh, it doesn't. Okay, good. So we have a compiler. So in this case, the short only has numbers from minus 32,768 up to plus 32,767. Okay. What this means, and you don't really have to care about this, is that the size of the chunk that it's using for computation is bigger and smaller. For an int, it's like this big. For a short, it's like half that. Okay? So the range. How about if we want to deal with a number that is bigger? If we have a short, we must have something else. If we have short, we have long. I'm not sure if this compiler accepts long or if we have to have a long int, but it probably accepts long. So we'll just give it a try and see. There we go. So a short only holds 3276, int holds up to 2 billion, and a long holds that number. That's really big, right? Hundreds, thousands, millions, billions, trillions, quadrillions. I don't even know what's after quadrillion. Septillion or something like that? Quintillion? So you can use really big numbers if you're using a long. Okay. Yeah? Yes, short and long do not hold any floating point numbers. They only hold integers. No floating point. Everybody good so far? I'm going to add a little C out to this so we can just see what's going on for each one of these. So we'll get a few more of these as we go along. All right, everybody good so far? Now, let me ask you a question. Say we have a program that counts the number of apples you have. Which one of these would you use? Short. How about if you're an apple farm? Int or long would probably be good. Are you using all those numbers to count your apples? Who thinks you would use all those numbers? Even for a short, who thinks you would use all those numbers? Who thinks this is a trick question? Because you're all staring at me like I'm going to put you to death if I answer it. Yes. You would not use the negatives, right? You would have a very bad apple farm if you used negative numbers, okay? So we have something in this that we can do. So I'm going to copy all these code and put them back up. And here's what we're going to do. If you add the word unsigned in front, What do you think will happen? It will start with 0. What do you think will happen on the other end? It will go up twice as far. Absolutely. So you can put the word unsigned in front of each of these. Oops, as long as you put it in the right place. Okay, so I've taken those integers, I've put the word unsigned in front of them. We will compile it. We will run it. And we will see that the ranges vary, okay? For an int, we go from minus 2 billion up to 2 billion. A short, minus 32,000 up to 32,000. A long, 9 quintillion. An unsigned int, essentially, instead of being minus to positive, goes from 0 to whatever the double of that is. Unsigned short goes from 0 to 65535, and an unsigned long is hundreds, thousands, millions, billions, quadrillions, quintillions. It's a big number. Really, really big number. Okay. So, everybody good with that? All of these are different types. Use which type is appropriate for the thing you're dealing with. Okay. Yep. They are also variable types. Absolutely. So if I wanted to declare some variables, I could do something like, you know, unsigned int apples equals, you know, and I know now that I have an unsigned int, I can go up to like 4 billion. 4 billion, 0, 100,000, 32 million, 986,712. And I should not get a compiler warning for that because it's big enough, right? So you can see I didn't get a warning. If I try to do the same thing with an int for more apples, it will probably give me a compiler warning because that number is too big. Okay. And it's going to do some stuff behind the scenes to make that work for us. It actually says it's making it a long instead of an int. So but you don't want to do that. Question?
Why would you not just choose to use long for everything?
Okay, so the question is, why wouldn't you use long for everything? The answer is that you should probably use long for everything, either long or unsigned long. But here's the deal. In the old days, like 10 years ago, remember when we talked about how the computer works? It works on chunks of data. What is the chunk of data size called? A word. A word has a bunch of bits in it. In the old days, a word was 32 bits. And so what would happen is that was the size of an int, was 32 bits. What would happen if you were using a long is it would get a second memory chunk and put them together, so you'd have two 32-bit chunks. Our computers switched to 64 bits. So now, by rights, sort of an int should be 64 bits, but because a lot of people wrote programs expecting an int to only be 32 bits and only goes up to 2 billion, it would confuse things if they went back and changed it, okay? So, you can and should just use long, it's fine. Most people use an int out of habit. Like I use it just out of habit. Also, it's one less character to type. So, other questions? Yep. Yeah, a little bit, yes. And I'm going to stop in a minute and talk about the project because it's coming up. So, and so part of that will be getting the right type. Now, if you use a long instead of an int, are we going to fail you for that? Nah, not really, right? So, if you use an int where you should use a float, are we going to fail you? Probably not, but we'll take a little bit off. Okay. All right, so these are all for decimal numbers. For float integer numbers, do you think we can use them for other things? How many of y'all think we can? I'm sorry, all the max that I'm showing you. Okay, so let's look at the floating point numbers as well. So let's just put float in here and see what a float does. Oops. What? Oh, I forgot to fill out float in here. See, I forget things too. Happens to everybody. Except, oh man. Man, float. Got it. Yeah. Thank you. Is it going to be work now? Or did I miss something else? Oh, I put it in the wrong place because I'm an idiot. That's why. Okay. Is it going to work now? How many of y'all think it's going to work? All right. Thank goodness. All right. So if we do types now, here's what we see. We've seen all this stuff before, but if we look at float, we can see that it goes up from like 10 to the minus 38 up to 10 to the plus 38, give or take. Is that a big enough range for your computation? More often than not. But just like we had long and short, we have what's called a double. I'm actually kind of curious on this compiler if a double is the same as a float or not, but I suspect it won't be. So yeah, a double goes up pretty high. So in general, if you're doing floating point math, you should use a double. Okay? I've been using float just because early on when we're talking about it, float is more descriptive, isn't it, than double? But double is what you call a really, really, really big float. It's essentially short for double precision float, which uses twice as many bits to store the float. Okay. Yes, sir? Yes. You can think of it that way. Yeah. Yes. In fact, I'm lying to you so much, you can't even believe it. You'll learn about it later. But conceptually, this is what's going on, okay? If you want to talk to me separately, I will tell you the truth. And you can handle the truth. It's okay. But yeah. Everybody good? All right, so those are the sizes of things. Let me just see if there's anything else. All right, there's one more that we can do, and we'll see if this compiler supports it. I think it will because it's part of the language spec. If that is not enough precision for you, you can use what's called a long double. And a long double is going to have lots and lots of decimal places available. There you go. Pardon? Excuse me? Yes. So you can see right here, float has 38 decimal places possible, double has 308 decimal places possible, and a long double has 4,932 decimal places possible. Yep. No. No, you shouldn't. Just use double. You have less typing to do. So, yeah. Yeah. Would your code be slower if you use long double? The answer is yes. The second question is, do we care how fast our code is? No, you don't. This is a preconception lots of people have. I used to have it. And the conception was that when you write your code, you should worry about how fast it is. And even when I was doing it, just a few years ago, it was totally the wrong thing to do. And the reason is that the computer is complex enough that as people, we have a really hard time figuring out what's going to make our code slow or fast. And it's not until you've written your code and you can use tools to test your code to see what's fast and slow that you can actually figure that out. So just don't even worry about it, okay? Can you use long double? You can. It's sort of overkill. So double is almost good enough for almost everything. Like, I don't know what mathematical calculations that you're doing that you're dealing like with more than 1,000 decimal places, right? So anyway, as a rule of thumb, I would use double. If you want to use long double, that's up to you. You'll confuse people, but they don't care. All right, so that's everything we're going to say about types right now. Everybody good with that? All right, in the last 2 minutes, let's talk about the project. When you look on Crackboard or whatever is there on my website, you will see that project 1 is posted. It has 2 parts. The first part is due next week. It is an algorithm design like you've had before, input, output, calculate, decide. The second part is your code, okay? You will be submitting your code again, just like we did for the last homework, through Blackboard for security and through Autolab, which submissions are not open yet. I hope to open them up next week, okay? So this week, you just do your algorithm design. The project this semester are all predicated on the fact that you are good programmers and you want to help the world, so you've been hired to work on a vaccine study. The vaccine is for the respiratory syncytial virus, It's not something you've probably ever heard of unless you're old or have a child. It is a virus that young people, very young people like babies and toddlers get, and old people get. It kills tens or hundreds of babies a year in the United States and thousands of old people. You've been hired to work on the baby part, which is pretty cool. There used to be, some people did vaccine work on this before. It turned out the vaccine actually made the disease worse, which was bad. So now the approach is, what's going to happen is doctors are going to inoculate the mother while she's pregnant. The mother will produce antibodies, which will be given to the child. When the child is born, they will have antibodies. Okay? The 5 projects this semester are all about this. One of them, the first one, is the intake form. That is, when scientists go out to study people, they will find pregnant women, they will enroll them in the study, and they have to get certain data from the subjects, from the pregnant women. With this data, they're going to calculate a variety of factors to see if they're suitable, and an overall eligibility score for the study. So it's a whole bunch of math calculations. As of now, you have all the math you need for it. By next week, you will have every coding thing that you need for it, so you'll be able to turn your code into a program. Take a look at it. Come with questions next time. Yeah? You did an algorithm design. The grading's a little messed up. I'm trying to get graded stuff back to you. I'm doing my best on that. So so I cannot guarantee that you will get stuff back, but I'll see what I can do. Okay? All right. Have a good weekend. Thank you.